Welcome back to Astronomy. In this video, we're going to look at the Earth and global warming. Much of what you hear and read these days about global warming and the climate are sensationalism and embellishment with much political motivation, and it very often ignores much of the science behind what's going on with the Earth and its climate. And so in this video, I'm going to give you a lot of the scientific principles behind global warming and climate, and so you can have a better assessment of what's going on. Let me first tell you about the greenhouse effect. The idea behind the greenhouse effect is that we get energy and heat from the sun. Here we see solar energy passes through the atmosphere, warming the Earth. But then, in the middle of the page here, some of the sun's energy is reflected back into space, and greenhouse gases in the atmosphere trap some of the heat, so it keeps our atmosphere relatively warm. The greenhouse effect is this idea that there are molecules in the atmosphere that trap the heat in. So water, carbon dioxide, and methane in the atmosphere absorb infrared radiation from Earth's surface. And you can see this model of a molecule. And the idea here is that when it absorbs the heat, it sets the molecule vibrating. So the molecule retains that energy. These gases then emit the infrared radiation in all directions, both outward toward space and downward toward the Earth. We can compare this with the planet Venus. Venus is an example of an extreme greenhouse effect. Its atmosphere is mostly carbon dioxide. And as you learned in Chapter 7, Venus has the highest average surface temperature, more than 800 degrees Fahrenheit. And whether it's daytime or nighttime, it doesn't matter. There's no cooling during the night because the atmosphere traps in the heat so well. On the other hand, in contrast, you have the planet Venus, which, although it's the closest planet to the sun, it is not the hottest planet. Certainly during the daytime, when the side of Mercury is facing the sun, it gets very hot, about 800 degrees Fahrenheit. However, at nighttime, the face of Mercury, the part of Mercury that's facing away from the sun, it doesn't retain any of the heat, so it gets down very, very cold, something like negative 300 degrees Fahrenheit. The reason is that Mercury does not have an atmosphere that traps in any of the heat. And then we have Earth, the privileged planet, which has an atmosphere that has a nice, good amount of greenhouse gases so that it retains the heat, whether it's daytime or nighttime, but it doesn't go overwhelmingly into the warming like Venus does. We get, during the nighttime, a little bit of cooling. And if you think about in Porterville, any given time of year, it'll drop down during the nighttime, maybe only about 20, 30 degrees difference. But throughout the Earth, a good steady temperature is maintained whether it's day or night. And that is very necessary for life, to have that stable temperature. Often in the media, the news, you see graphs like this that show the global temperatures. And so here's something, you see the vertical axis 50, 52, 54, and this graph goes all the way back to 1900. And I say all the way back rather sarcastically because that's not very far back at all, just a little over a century. And you'll see in the media this little bit of this slight little increase. There's a zigging and zagging, but a slight little increase in a trend line. And then they will say, look, over the past century plus, the temperature on Earth has been rising. However, in order to understand what's really going on with the climate, we have to extend the graph back more than just 100 years. We have to go back thousands or even hundreds of thousands of years to appreciate the trends that are going on. Here you see in this graph, from 1900 to 2000, the last century, is just this little uptick where my marker is. But you notice if we're going back a few thousands of years that there are ups and downs, that Earth's climate, Earth's average temperature, goes in cycles. This black line in the middle represents the average temperature over about a 3,000 year span. And certainly over that 3,000 years, there are times when it's been higher, sometimes when it's been lower. And actually, as you look at the end of this graph, in 2006, we're actually below the 3,000 year average. And I want you to think about, very often in the news when this is given to us, there is blamed for the rise in temperature industry and vehicles and things that we've invented, modern inventions to make life more comfortable. And they say these are the fault, these are the reason that the climate is going up. Well, actually, the climate, the temperature is just a little bit lower than over the past 3,000 years, way before we've had any of those modern inventions. And then you compare that with this graph I showed you earlier. This graph just shows 100 years of trending, and it just doesn't give enough information. Let's take it back hundreds of thousands of years. Now, certainly there were not thermometers or even people going back that far, but scientists have come up with very sophisticated methods of seeing what the temperatures were like, even going back hundreds of thousands of years. If you look at this, you can see on the horizontal axis on the right on this timeline is today, and then we go back 100,000 years, 200,000 years ago, 300,000, and 400,000, and average temperatures on the globe. And I want you to see that there are these cycles, these ups and downs that the Earth's temperature goes through. And these are different periods that are called glacial periods and interglacial periods. Think of those glacial periods as ice ages. So the glacial periods are when the temperature of around the planet on average was very low. And then the interglacial periods is the warmer periods between the glacial periods when there were many glaciers. So the cold glacial periods, these cycles are about every 100,000 years. And then the warmer interglacial periods, they're shorter lived. They last about 15,000 to 20,000 years. The current interglacial period, the one we are in right now, began about 18,000 years ago. So when you're told that warming of the Earth started about 100 or 150 years ago, that's not true at all. Actually, the warming started about 18,000 years ago, and we see that glaciers have been retreating for about 15,000 years. Now, in ancient and modern history, we see these little ups and downs. So you just saw on the previous slide the large cycles that last about 100,000 years per cycle. But then there are the smaller ups and downs, the smaller mini cycles. And since ancient history, recorded history, we see a variety of ups and downs, and I want to tell you about some of them to give you a better feel for what's been going on with Earth's weather just in the past century and a half. We see evidence that around the year 4000 BC, temperatures were higher than they are today. Now, there are many ways that scientists use to figure out what temperatures were doing during these various periods, and some ways involve agriculture. So where plants are growing, different types of farming done at different parts of the world, that tells you when it's warmer or cooler. For example, grapes, such as for wine, tend to grow in warmer climates. Going down towards the equator. Certainly in California, we grow grapes. We don't grow grapes in Canada, Newfoundland, places like that. However, there are times in history when grapes were grown in Newfoundland in Canada. When those places were discovered by Europeans, grapes were found growing. And then we can also look at where people in ancient times built harbors, where they built ports. You probably know that when the earth overall is warmer, sea levels tend to be a bit higher. And so the level at which they built ports is an indication of what sea levels were doing, which is an indication of what the temperatures were. Well, let's look at this list. There is what's known as the Cold Period from about 600 to 200 BC. Now, keep in mind, when I give these dates 600 to 200, these aren't discrete dates where suddenly it stopped being cold, but these are rough guidelines. Certainly when the Earth goes between warming and cooling, it's a general trend that sometimes takes about a century to start to recognize. So these are rough guidelines from about 600 to 200 BC, what historians call the Cold Period. And then the Roman warming period, which is just named that because the dominant culture in Europe was the Roman Empire, the Roman culture. That lasted from about 200 BC to AD 600. So this was a time of warming. And then there was a time of cooling again, what's called the Dark Ages Cold Period from about 600 to 900. In fact, some social historians think that maybe the Dark Ages, which is more of a social commentary, that label is the Dark Ages, was perhaps caused by the cooling of the world, which would lead to less agriculture, which could lead to famine. And then as Europe came out of the Dark Ages, there's the medieval warming period, more agriculture, so less famine and starvation, and more growth in economies, the medieval warming period from about 900 to 1300. And scientists have figured out that it was actually warmer then than it is now. It brings us to the Little Ice Age from 1300 to 1850. This was the time of the Maunder Minimum in the chapter 14 video talking about sunspots. Remember, I said that there was this roughly 70-year period from about 1645 to 1715 where there were very few sunspots, very little solar activity, and that was during the Little Ice Age. Which brings us to the warming period, that the trend started actually in the early 1800s, but the warmth was really starting to be felt around 1850. And depending on how we divide up these different times, you could say that the warming went from 1850 to about the year 2000. But it would be more precise to divide it up and to show that in the midst of that, there was that short warming from 1850-ish to about 1940. And then the world was cooling between 1940 and about the mid to late 1970s. And then the warming continued, so starting in the late 70s up to about 2000. And it seems that the warming stopped, regardless of what you hear on the news, that the warming may have stopped around the year 2000. Sometimes it takes a few decades of retrospective data collection to tell, but it seems that the warming basically stopped around the turn of the century. Let's look at a map from the medieval warming period. This is from about 10th century AD. And I want to show you how the warming and cooling, how this affects people. And so if you look at this map, here you have the Vikings as they were exploring, as they were settling. So they came west across the North Atlantic Ocean. So they left, here's Norway and Sweden and Finland. And they came west and they found Greenland. Now, Greenland, we think of it as a very snowy, cold area, but they named it Greenland. Why would they name it Greenland? Well, because it was much warmer than it is now, and there wasn't all the snow. So when they came across Greenland, they saw green pastures, a wonderful place for them to settle. So the colonists settled, and here is the what's known as the Eastern Colony, actually on the southern tip, the Eastern Colony, and here is the Western Colony. So those were the two main colonies where they settled, and they also ventured up the west coast of Greenland, and they found their way to Newfoundland. It was named Vinland, and why was it named Vinland? Well, it was the land of vines. I mentioned to you a bit earlier in this video that grape vines don't grow in cold climates, but that's what they found there in Newfoundland. So they called it Vinland, and that was just a mention of that they were finding grapevines. Well, eventually, as the centuries went on, we get into the 11th century, the 12th century, 13th century, we start getting into the Little Ice Age. So these colonists had been benefiting from the medieval warming period, but then the Little Ice Age started to kick in, and it started to get colder and colder. The oceans started freezing up. And so supply ships that they relied on started having to take more southerly routes to avoid the ice. And there was a point at which, a few centuries later, the supply ships just stopped coming because it was the oceans were too treacherous. Now these colonies, they eventually died out because of famine, because of the cold. Now you think we hear all this doom and gloom these days about warming, all this bad stuff that can happen from warming. But actually, when the Earth is in a warming trend, that's when we get good agriculture. It's actually the cooling we should be more concerned about. When the cooling happens, that's when there's less agriculture and more ability for famine. When I was in elementary school in the late 70s and early 80s, we were not at all concerned about global warming. In fact, the doom and gloom was all about global cooling. And they were frightening the little school children, telling us about how we were going into an ice age, how the world was going to freeze over. And it was very similar to what you hear now about global warming. But back then, few decades ago, it was global cooling. Now, this is from an article in Newsweek magazine, April 1975. It says there are ominous signs that the Earth's weather patterns have begun to change dramatically, and that these changes may portend a drastic decline in food production, with serious political implications for just about every nation on Earth. And so here, the doom and gloom about climate change, but at the time they were talking about how cold it was going to get. We were going to get into an ice age. Average temperature change going back about a century, and this is actually decreasing amounts. So going up in the graph means getting colder. And so they were scaring everybody with how it was getting colder. And there's the graph zoomed in. And then you fast forward a couple of decades, the cooling was over because it wasn't something that was being caused by automobiles or industry. It was just natural cycles that the Earth goes through. But now we go forward a couple of decades and we see articles like this. Special report on global warming. Be worried, be very worried. Climate change isn't some vague future problem, it's already damaging the planet at an alarming pace. And then again, you have global warming, climbing temperatures, melting glaciers, rising seas all over the earth. We're feeling the heat. Why isn't Washington? And the implication is that our government should be doing something about it, as if there's anything to be done about natural cycles that the earth goes through. And the poor penguin who's trapped on the snow, the Global Warming Survival Guide. And so we've been getting this for a couple of decades now, just this doom and gloom about how it's getting warmer and we need to figure out how to survive it. This is a picture. that was deceptively used in a popular propaganda movie a few decades ago, and the narrator said, "Those poor polar bears, where will they go?" And the implication is that they're trapped on this ever melting bits of snow, and when it finally melts away, they're going to drown in the sea. And the photographer who took the picture came back and said, "No, you misrepresented what was going on in the picture. There were many polar bears all swimming back and forth between the land where we were standing and the snow, and they were having a great time, and polar bears can actually swim pretty well." But it's just an example of a lot of the propaganda and the deception that's behind pushing this global warming and this climate agenda. Let's look back at Earth's greenhouse gases. When you hear about greenhouse gases, you most often hear about carbon dioxide. But carbon dioxide isn't the main greenhouse gas in our atmosphere. It's just the one that's easiest to find a culprit and point the finger of blame. Actually, water vapor is the number one greenhouse gas in our atmosphere. There's also carbon dioxide, there's also methane, nitrous oxide, and ozone. So these are the molecules in our atmosphere that absorb the solar radiation and then re-emit it as infrared in all directions. Some of it goes up out of the atmosphere, out into space, and some of it gets reflected downward. Now, most often, the warming is blamed on industry. They say it was about the time that the Industrial Revolution started. We started burning hydrocarbons, putting this into the atmosphere, and that is what has caused the warming. Well, we can look at this, what's going on with the global temperatures, and relate it to the worldwide burning of coal, oil, and gas. And it sheds a lot of light on what's really going on. So first of all, you can think of this blue curve right here as being a measure of the Earth's temperature. Now, that in itself is a very tricky thing to measure. How do you measure the Earth's temperature? Because the Earth, you go all around the world to different countries, to different states at any given time, and the temperatures are all fluctuating. So it's a very tricky thing to come up with to say what is one number that represents the temperature of the Earth today. But in this particular graph, what they've used is a measure of different average glacial lengths. So the size of glaciers. And as it goes up, that you see negative numbers, -4, -8, -12, and that means going up on this graph means that the glaciers are retreating. It's indicative of warm weather. So if you don't want to get bogged down in the details, you can just think of up on this graph as being an indicator of high temperature. So we can see as we watch the blue curve, it starts up and it goes a little down, so a little bit of cooling, and then it starts to rise and it goes up to where we are now on into the 21st century. And people look at this and say, look, it started around the Industrial Revolution. However, this black line here represents a best fit line, meaning it's a good way of seeing when did the warming trend actually start. And you notice it actually started right about here, about 1820. And that is several decades before the Industrial Revolution. So we can't blame the Industrial Revolution for the beginning of the warming, because when we first started burning coal, the warming trend had started about 30 years prior. And even then, 1850s, 1860s, 1870s, this gray patch represents how much coal was being burned. It's measuring metric tons of carbon used in the billions. But there really wasn't that much worldwide. It started to pick up 1900, 1910, 1920. By this time, the warming trend was fully in effect. Then we get into the advent of automobiles. So you see the blue patch. We start burning oil. 1950s, more and more gasoline being burned. And so you think about the era of the muscle cars, when we weren't really concerned about how much gasoline we were burning, the 1950s and 1960s. And the warming trend had been going on for more than 100 years. In fact, this was the time when a slight cooling trend started. And up here in the blue, you see this very little slight cooling trend that went on for a few decades. So what we can see from this graph is that there isn't a very good correlation between the increase in carbon being burned, carbon being used, and the warming. And in fact, it can't be causation because the warming trend started before we started burning carbon. I want to suggest to you a better correlation, looking at what outside of our planet might be causing the warming and the cooling. And remember, these warming and cooling cycles go back hundreds of thousands of years. One thing we can look at is that the sun goes into various cycles. Now, I mentioned to you back in chapter 14 that the sun has sunspot cycles that are about every 11 years. And sometimes the cycles are longer, slightly longer than others. The sun has much more complicated cycles that I did not describe in chapter 14, but scientists have found that the sun's cycles are well correlated to the Earth's climate cycles. This graph, for example, shows in the red solar activity measured in irradiance, basically how many watts per square meter, and it very slightly fluctuates with ups and downs. And that correlates well to the blue zigging zagging graph, ups and downs of temperature. So scientists are looking at what exactly are the relationships between what the sun is doing and what our climate is doing. And they found very good correlation. It's a better correlation than looking at the world hydrocarbon use. This graph shows alongside each other world temperatures with the solar cycle length. Let's first of all look at the temperatures. We see this goes back to 1860, so temperature going up, there's a bit of a dip, a general upward trend. Remember, there was a downward trend, the cooling of the 40s, 50s, 60s, and 70s, and then an upward trend. And now let's look at the red curve, which is solar cycle lengths. Remember, a solar cycle is roughly 11 years, although sometimes it can be a little shorter, sometimes it can be a little warmer. And so if you look at these red numbers on the vertical graph, up high is a short solar cycle, 9.5 years, and down low, 11.5, averaging out to be about 11 years. And what they see is that there's this nice correlation between when there are shorter solar cycles, there's higher temperature. And when there are longer solar cycles, there are lower temperatures. Now, remember what solar cycles are. This is indicated by how many sunspots there are, what percentage of the sun's face is covered by sunspots. And we say it's at solar maximum when there's a lot of sunspots, minimum when there's not many or any at all sunspots. And so that's roughly about an 11-year period. Remember that the sunspots are not causing anything. The sunspots are just a visual indication of that there's magnetic activity on the sun. And so scientists are looking, they're exploring what is the relation between magnetic activity on the sun and the solar flares and coronal mass ejections that are caused by that magnetic activity, and how all that relates to the Earth's climate. Here's another one we see as we look at the trend of temperatures. Certainly there's the zigging and zagging, but these are best fit lines. There's an upward trend in temperature, downward trend, upward trend, and that relates to various solar cycles. This is a picture of Mars's polar ice cap. Mars has polar ice caps just like Earth does, except ours is made of water, ice water. Mars has carbon dioxide, so frozen carbon dioxide, and the trend has been over several decades since we've been observing, those polar ice caps have been decreasing, they've been retreating. So just a bit more evidence that this isn't caused by driving SUVs or burning hydrocarbons. It's not just something that's on Earth. It's also a trend that's been going on Mars. So whatever is causing the glaciers retreating on Earth, it's also happening on Mars. Later in the semester, we'll be learning about stars and we'll be learning about what goes on throughout the galaxy. And one of the things we see when we look out in space, there are cosmic rays. Now, cosmic rays, these are particles, energetic particles that come from stars, particularly from stars that have died and gone supernova. And there are regions in our galaxy that have more cosmic rays than other. And we on Earth are protected by these cosmic rays. They could, in large amounts, be dangerous to biological tissue, to life. However, we have 60 miles of atmosphere that blocks us from these cosmic rays. Now, it's been found that cosmic rays cause cloud formation. So when there are more cosmic rays, when the Earth is in a region of space where there are more cosmic rays, we tend to get more clouds over the Earth. And this has been shown both in our atmosphere and also in simulated atmosphere in laboratory conditions. But cosmic rays cause cloud formation. Now, when there are lots of clouds, we have a cooler climate. So you think on any given day, if there's a summer day and we have clouds, that's a good thing. It feels good because it's not going to be as hot of a day. So the clouds have a cooling effect. Now, when that's going on worldwide, when there are more clouds, we're going to have overall a cooler world. So here I have in this picture, these cosmic rays, they come in from all different directions, and essentially they cause cooling. Now, when the sun has more activity, more solar flares, a more intense solar wind coming from the sun, the solar wind tends to block or it tends to deflect those cosmic rays so that not as many cosmic rays are getting to Earth. We don't get as much cloud formation or as much cooling. Therefore, when there is heavy solar activity, and you can see those sunspots there in this picture, heavy solar activity, we get a 1-2 punch from the sun. The first part is more solar activity is going to lead to more energy coming from the sun and thus warming the Earth a bit more. But the second part of the 1-2 punch is that more solar activity blocks or it deflects away the cosmic rays so we don't get as much cooling from clouds. And so there's a strong correlation between what's going on with solar activity and the warming or cooling of the Earth. Now, as the Earth moves around the galaxy, as we'll discuss when we get into chapter 19 on the Milky Way galaxy, as I said before, there are regions where there are more cosmic rays and less. And scientists have found that where the Earth goes as it moves through the galaxy actually correlates well with these glacial and interglacial periods that, remember early in this video, those 100,000-year cycles. And I also want to remind you of the Maunder minimum, just looking at historically the number of sunspots on the sun. And there was this time for about 70 years when there were very few sunspots. And that is related to a much cooler period over Earth history. As I conclude this video, you might be thinking, but I'm always hearing on this news, maybe all my life, I've been hearing about how scary things are with the warming. I want you to understand that environmental scares have always been going on throughout human history. And I think back in ancient times, whenever there was a solar eclipse or comets in the sky, people would be getting very, very scared, wondering what is going on in the sky, what's going on with the earth, is this going to be the end? And I want you to see just in more modern times, there is always, with every decade it seems, there is an environmental scare. And I think back, just going back to 1865, when the Industrial Revolution was just getting started and people were starting to rely on coal. And there was a scare being put out by the newspapers. Great Britain will run out of coal in just a few years. There will be no more. So don't get too attached to these trains and industry. In 1914, when we were getting dependent on oil, automobiles were running, and by that time airplanes had started flying, and there was a scare that the US oil reserves will run out in 10 years. And then again in 1939 and 1951, newspapers putting out that the US is going to run out of oil in 13 years, and certainly none of these things happened. In 1968, there was the big scare of the population bomb, that world population was going to get out of control, and by the 1970s, there's not going to be any room or any food for anybody. And through my life, I remember being told that when the Earth gets to 5 billion people, when the Earth gets to 7 billion people, when the Earth gets to 9 billion people, it'll be completely uninhabitable. Again, just the environmental scares. In the 1970s, we're being told the world's oil supply will run out by 1990. In the 1970s, and this is, I remember, as I mentioned to you from elementary school, we're being told that a new ice age is coming. In the 1980s, the big scare was acid rain is going to wipe out all the forests. Also in the 1980s, the ozone layer is disappearing and we're not going to have any protection from ultraviolet. And today, to quote former Vice President Al Gore in his propaganda movie, the Earth has a fever. And to quote another politician just a few years ago, the world is gonna end in 12 years if we don't address climate change. So there are always these scares, often by politicians who want you to vote for them because they are going to fix things for you. This is a quote from the first Earth Day celebration, 1969, from a prominent scientist. Thinking about the scientist was addressing the cooling that the Earth was going under, the global cooling, and the scientist said the threat of a new ice age must now stand alongside nuclear war as a likely source of wholesale death and misery for mankind. The cooling since 1940 has been large enough and consistent enough that it will not soon be reversed. And I want you to think about that wasn't that long ago. That was just a few decades ago. This scaring us with the cooling will not soon be reversed. That was in 1969, and yet that trend naturally ended. The cooling trend naturally ended about a decade later and started the warming trend. Again, at that time, the scientists said civilization will end within 15 or 30 years unless immediate action is taken against problems facing mankind. And specifically, the context of this quote was unless we take specific action to reverse the cooling of the world. And this is the same kind of stuff you hear now today, but it's just about warming, how the sea levels are going to be rising. There's these predictions going back to the 1990s. Sea levels are going to rise by 2 or 3 feet by the year 2010, by the year 2020, and we see it's just not happening. By 1995, somewhere between 75 and 85% of all the species of living animals will be extinct. So, different decade, we just have different scares going on. The Earth has been going through these ups and downs of temperature long before man got here. These ups and downs, these are natural cycles, and they are very astronomically related. They are related to the sun, they're related to our position in the galaxy. And the Earth and the solar system have a wonderful way of naturally maintaining the balance. So there isn't a severe upward trend, a severe downward trend. There's just the ups and downs, and it goes in cycles. Remember that there have been ice ages called the glacial periods, and there have been the interglacial periods. We just happen to be in an interglacial period right now. And that concludes the Earth and global warming. Have a great day.